Right. Anastasia, long time no see. How you going?
I am currently sick. How are you?
Oh, shucks. Hey, boy. I asked that question in vain, boy. You good? Well, I hope you recover soon, eh? I hearing real people getting sick these days.
I hope so too, because
I feel
this
like
this is
boy.
not something you want.
I think Kadisha told me she was sick too, She's still recovering from it. Yeah. Don't know what's going on. Right? But thank you for joining class though. Thank you for joining class. Even though you're sick. You just had to be here, right? And like even if you're not answering much questions, like just soak it in. Yeah.
Okay, no problem. I wouldn't talk much either way because I'm wheezing because I'm an asthma. So yeah.
It's all right. I rather they just be here and just chill rather than just not be here and not watch your recording. Because chances are, let's be real, right? Most of them not gonna even watch your recording. After class, it's like, no, no. Oh, still send a recording? What? Yeah, we're not gonna watch our recording after class. Yeah.
Yeah. Sick.
I'm gonna start. Great. So Simran, let me know if you're hearing me.
Blech. Yeah.
For say, you have me said I hear you say, bruh.
Ah? Oh my god. You was not supposed to hear that I was talking trash talk to someone on the game. My bad.
Okay. That's okay. Yeah, Simran, you there?
Yeah.
Okay, nice, Simran. Let me run through this. So, wait to give you a question I'll read.
The circle shown below has center O and the points A, B, C, and D lying on the circumference. A straight line passes through the points A and B. Angle CBD equals to 49 degrees and angle OAB equals to 37 degrees.
Simran, it sounds like you're about to cry. You okay? You good?
Yeah.
All right. So, they want me to write down the mathematical names of BC and OA. All right. So, this is B to C. What B to C looking like?
Hyperscant.
April what?
Hyperscant. That's how it's pronounced.
Secant, April?
Secant, yes, that is it.
This would be a secant. For something to be a secant, it needs to be inside the circle and outside.
Oh,
Could somebody tell me the name for this? It connects 2 points along the circumference.
A chord.
Right? Simran, that's supposed to be chord. It's chord, right?
I was double thinking, then I was like, the next thing is not four. Because I went back and watched the example and I was like,
You see, if it was like this, no, then that would be a secant. It was like that. Then it's a secant. Yeah. Right? O to A. What is O to A looking like? So it's starting from the center and it going to the circumference. What's that?
I put radius.
You'd be correct. That is radius. Nice. And if I connected O to C, what would A to C be?
That would be
Diameter.
Wait, Simran. Yeah. So if you have a question, if Simran doesn't get through with it, I'll call upon somebody else. Right? But Simran, A to C is a diameter, right?
yeah.
Okay, I'm just doing a recap. Question, what would this line here be? What would I call that?
That would be the tangent.
Right? That's a tangent. What about this?
Um, forget how to pronounce it. A secant.
Yes. Yes. Right? Great. What would I call this area over here?
Um,
Also start with S.
that would be a segment.
Yeah, segments. Would it be a minor segment or a major segment?
A minor segment.
Right, this would be the major segment. Okay, I'm asking a tough one. What do you think this would be?
A sector.
Okay, Simran. Big up you. Okay. All right. And what is this? It's actually a trick question. It's not actually a part of a circle, but it is a shape that I taught you. What kind of shape is that?
Um, is a triangle.
Yeah, it's a triangle. But what kind of triangle?
Mm.
That's what I.
Isosceles.
You know why is I isosceles?
Because two sides are equal.
Which two sides equal? Is it AB and OA? Is it AB and OA? What do you think? What two sides you think equal?
Um, OA and OB.
Right, because both of them are what?
Standing on the
Nah, nah. Mm-mm. What would I call O to B? What is O to B called?
radius.
Right? What is O to A?
Radius.
So both of these are radius. Well, both of these are radii, right? It's plural. And in a circle, isn't the radius the same everywhere?
Yeah.
Think about it, right? Simran, if the radius wasn't the same everywhere, wouldn't we end up with something looking like this? Watch. The radius here will be different from the one over. Wait, let me get like a more extreme example. Do you think this is a circle?
No.
That's clearly not a circle, right? If I go to find the quote unquote radius, wouldn't the distance from here to here be different from like here to here?
Yeah.
So to form a circle, the radius needs to be the same everywhere, right? So that's why it's an isosceles triangle. Great.
Boss man, draw Flintstone tire, boy.
Yeah, right. I don't know if these people don't know about Flintstones on here. I don't know about definitely don't know about Flintstones. Simran, you know about Flintstones?
Um, yeah, but I never used to watch it. So,
Oh, Anna, I feel like you had to know about Flintstones. I don't know if Anna here. Who else old in this class, boy? Hmm. Hmm. Perseus, you know about Flintstones?
Heard about it.
Okay, you're not old enough. Jada, you know about Flintstones?
Yeah, I think so.
You ever watched Flintstones?
Probably not.
Yeah.
So basically, for those that don't know, it's basically an old cartoon show about caveman. That's it.
Yeah,
The
yeah, that's it.
Well, I
concept.
don't know about Flintstones.
They don't know about Flintstones.
I just looked it up. Yeah, I actually don't know about it.
Flintstones.
And I had this other one. Had this other one I used to watch. Like with the UFO one. Who's the one? I know, tell me what it is now. I know it is with like it's in space. I'm thinking of Daphne in it.
No, that
I
is
know
the
what
other
you're talking
family. That the other family with
Wait,
the
no.
dog
What's the
and
name
one
of
of
that
them in
one?
space.
What's the name of that one though?
I
I
can't
don't
remember.
know, but I know what you're talking about.
Um,
Exactly.
I used to go hard though. That was a real boss show. Um, now I'm trying to figure it out.
Hold on, I go check it.
The Jetsons. I think. Is it
Yeah.
Jetsons? The Jetsons. Yeah. That's it. Yeah, man. That I used to go hard. To. All right. So, Simran, before we even go any further, I want you to see. I want you to try to figure out which circle theorems we might have to use. So, Simran, are you seeing any circle theorems that you could use in this question?
Um,
So look at the diagram and tell me if you've seen it. By the way, somebody with the notes, or they could take a screenshot of the circle theorems and send it on the chat. Chelsea, since you just joined the group chat and you wouldn't have access to that, so let me just send it back. Just send back the notes on the chat. Right. So Simran, you're not sure if you've seen any.
no.
Okay, I like the honesty. I don't mean in a sarcastic way. I'm glad you tell me you're not seeing it. So this is the first one you should be seeing. So Simran, this is a diameter, right?
Yeah.
If you have a diameter and it cuts the circle in half,
Yeah.
so the first one of the first theorems you should see is angle forming a semicircle is 90. So you see this triangle here?
Yeah.
Right. So the angle forming a semicircle, this angle is 90. That's the one you should be seeing. Are any of you all in class seeing another theorem?
I actually
Oh,
I
Somebody,
actually see the 90 degrees by the 49 B to C.
you saw that one as well?
Yeah. Isn't that 90 degrees as well?
This is 90 and this is 90 as well. Yeah. This is the one you see?
Yeah. Well, that's it.
Yeah, because
That's why I used to work out X.
because if you were to connect it, you'll see that this is also a triangle that's in a semicircle. You see in that? Yeah or no? Like watch. If I connect A to C, don't I cut the circle in half?
Yeah.
Yeah, and the angle forming a semicircle is always 90. Great. Are you all seeing any theorems? Guys, tell me. Are we seeing anything? Somebody drop something in the chats. Sky, you know how to put it in the chat. You could unmute and tell me. Because you're very correct. Correct. So tell everybody what you say.
That's the ABDC, the two triangles standing on the same arc of so they are equal.
And what chord are they standing upon?
BC.
Right. Yeah, again, it's kind of hard to see, right? But if I connect this, then you could clearly see that that angle and this angle, both of them standing up here. See it, right?
Yeah.
Nice. Let me see if I see any. I mean, I see that you could use if you wanted, you could use isosceles. That might help you. Um, additionally, I don't really see any others. So let me just jump straight into it. Right, so Simran, we gotta find angle x. Angle x, right? How are we going to find for angle x? Tell me, Simran, how are we gonna find for x?
I minus 90 plus 37 from 180.
Yeah, actually, no, that's wrong. Simran, if you wanted to do that, then the triangle would have had to look like this 90. Yeah, does the triangle look like that? Nah,
No.
okay. But it's okay, right, Simran? So, Simran, just remind me, any triangle adds up to how much degrees?
180.
Right. We know that. So if we could figure out two of the angles, then the other angle will be easy to find. So here what? They want us to find for angle x. So we're looking at this triangle. So we're looking at that triangle. Remind me, what kind of triangle is this?
Isosceles.
Right. So if this is 37 degrees here, what it should be?
37.
Right. This should be 37 degrees. All right. Now, I want you to notice something. If you add up this and this, you're going to get 90. No, you're not going to get 90, which is weird. I think CXC on crack. But the only reason they could justify that is this don't fully connect to here. And so that's why. But do you understand that because this is an isosceles triangle, this would have to be 37 as well? Yeah?
Yeah.
You sure you understand that?
Yeah.
And if this is 37 and this is 37, how would I find for x?
You just add the 2 and minus it from 180.
Tell me what you write. So x would be equal to 180 minus
37 plus 37.
right All right, so let me just get the Casio calculator to the side. So like Sky, you'll get to see how to use it one time. So I mean, pretty basic. You're gonna put 180, right? Minus open bracket 37 plus 37 close brackets, press equal and should get 160 degrees. So Sky, you go let me know if you get the answer, right?
Yes, sir.
Nice. So I'm just gonna put that in one time. This is 160 degrees. CXC dotish. This supposed to be 43. No, not 43. 53. So it'll be 53 degrees. Yeah. CXC just do some things like that at times. Right? So the answer for X would be equal to 160 degrees. Right? And the working for that is 180 degrees minus 37 plus 37.
Exclusive.
Yeah?
37. Where did second 37 come from?
Okay. Let's check this, right, Joshua? What kind of triangle is this?
Isosceles triangle because they're
Because,
both OA and OB. They're the same width, the same size.
right? Because both of them are radii, all right? We know that. So in an isosceles triangle, are any base angles the same?
Yeah.
So if I put any line here, and I put any line here to show that both sides equal, would any base angles be located here and here?
Yes.
So if this is 37, this would also have to be 37. Because remember, in an isosceles triangle, and base angles are equal.
Yes.
So let me know if you understand how I get it 37. Because it's an isosceles triangle. If this is 37, this had to be 37 as well. Yeah or no?
Yeah.
Yeah, okay. Right? So
Where's it? Hold on. Where's it? Oh wait. No. Never mind.
check the position of it, right? The base angles are located right next to the equal signs. So be there and there, right? So Simran, what was the reason I used to figure out my answer?
Um, because it because what's standing on the face.
Nah. All right, so Simran, let me try to understand this, right? So the basic concept of where to get is that if you have two angles for a triangle, you could figure out the other one. So how did we figure out that this was 37 degrees? First question here.
Because it's an isosceles and the
Right? So
base angles is equal.
so we need to say how we know it's isosceles. So you would say that triangle LB ABO is an isosceles triangle. Okay, you just say triangle ABO is an isosceles because OA would be equal to what? Tell me, Simran. OA would be equal to what? Which other side is it equal to, Simran? Tell me.
OB.
Right? So here what? We establish a triangle ABO is an isosceles, right? And then another thing, base angles in isosceles triangle are equal. So if that's the case, then therefore we would say that angle OAB is equal to what angle there, Simran? So we just said that angle OAB, which is 37, is equal to what? Which other angle?
Kind of confusing.
I say that again.
Yeah.
So AB, I mean AOB. So you need to say this angle in terms of that notation. So this would be, how would I write that?
That would be OBA.
Nice. Right? And since the base angles are equal, you're allowed to say, right? You're allowed to say that, you're allowed to do the calculation, right? And then the last thing you use was sum of angles in a triangle is 180 degrees. And that basically explains how we did this. So let me know if you fully understand that. Yeah. Yeah or no?
Somewhat.
Somewhat or 100%?
No, I could explain that.
All right, so Simran, first things first. What kind of triangle we have here?
Isosceles.
Right, but we need to tell them why is an isosceles. So I said triangle ABO is an isosceles because this and this length, those two lengths are equal. Some of that confuse you. Are you with me so far?
Oh, wait, yeah, so far.
Right, so because both of these are radii, triangle ABO, which is the entire thing here, is isosceles. The next thing, base angles in an isosceles triangle are equal. So in other words, you see how this side, you see these two sides how they equal? Then the base angles would have to be equal as well. So if this is 37 degrees, this would have to be 37 degrees as well. Say it with me so far.
Yeah.
So that is how that is why I said angle AOB is equal to angle ABO. So that's why this and this have to be 37, right? And the last thing I used was the fact that all angles in a triangle is 180. Because then we use that to figure out the final answer.
Yeah.
Right. So that's it. That's all the reason they could want. Don't have anything else we can really tell them. All right. Is there anybody that didn't understand that? Sky, you okay so far, right?
Yeah, so I make a mistake when I was doing the homework, but I understand my mistake.
What mistake you make?
So I do some sharpness, like in 2A. I don't know how my answer ended up 53 instead of 106, but
Well, yeah, that's a
yeah,
bit interesting.
yeah. So the reason why is because add minus 37 from 19. I'd make that mistake.
You had minus 7 from 90.
Yeah.
90. Why?
But I don't even know what was going through my head. I think I was focusing on the next angle in the semicircle.
I feel so.
Yeah.
So, but
So,
like you understand what I'm saying, right, Sky? Once you have two angles, to find for the last one real easy.
yes, I understand. I know.
Nice. Angle Y. So Sky, you're gonna help me find for angle Y. Right. Let me not assume anything, right? Let me not assume anything. So Sky, is this connected to that?
Yeah, so
No, it's not. Like I don't see a connection here. You see a connection?
wait, no, sir, not.
Yeah, so we technically can't use that theorem that says, angles standing on the same chord are equal, because I'm gonna ask that question. Is it really standing on this?
No,
Is it really standing on this?
no,
Yeah or no?
no.
Nah. It's on this, it's on the diameter. So we technically can't use that. But tell me, Sky, are we still allowed to use this theorem?
Yes, sir.
Yeah. And let me just say why, right? The reason for that is because the angle in a semicircle is what?
90 degrees.
Right. We could use that one for sure because and we have a diameter cut any circle in half.
Yes, sir.
Right. So here what? Do we know what two of the angles are for this triangle?
Yes, sir. 49 and 90.
Right. So how would I find for angle y now?
Um, so I could tell you how I did it and the answer I get.
Wait, so let me just do this fast. And the answer right there. So Sky, tell me, do we know what the two angles are equal? Do we know what two of the angles are inside the triangle?
90 and 49 degrees.
Right. So is it possible for us to figure out the last angle?
Yes, sir.
All of the angles supposed to add up to what?
180.
Right? So I'm going to put 180. I'm going to minus 180 from what? Well, I'm going to minus what from 180?
So the total are 90 and 49.
Right? So that's going to be 180 minus 139. That should be 41 degrees.
Yes, sir.
You get that?
Yes, sir.
Okay, now how you do it?
So I think I actually just I kind of do the same thing.
Okay.
Same thing.
So, I mean, you see why you couldn't really use, angles standing on the same chord are equal. Couldn't I use that? Because it wasn't going it wasn't going to C. Understand?
Yes, sir.
Yeah. So if you understand that. Is there anybody that's very confused by this question? Tell me, guys. Are we very confused? Or are we okay? Joshua,
Okay.
we okay? Nice. Ria, let me know if you're okay.
41.
Nice. That's correct.
Yes, I get it.
Situation. The angle in the semicircle is 90.
Right? Yeah. And then the summer angles is always 180. Right? Adetola, Jada, Precious, Anna, Chelsea, Carissa. Are they okay?
Yeah.
Yeah,
Yes,
okay.
sir.
Gonna move on, right? Right. Yeah, so the reason for that was pretty easy, right? So let me move on. Was that it for this question? If so, that would be, yeah, that, wow. That's an easy question. That's an easy question. I'll you one question like that for the exams. Hey, Joshua, you have a question like that for, for the exam?
For what? CSEC or
Yeah,
any?
CSEC. CSEC.
I think so. I don't know really, to be honest.
No, but like, was the question easy?
Yeah.
Yeah. Well, we hope like get like an easy-ish question for the exam. Right. So I want somebody that confident in circle theorems to help me with this one. Because this one thing's gonna get a bit messy. Who's confident in circle theorems?
So I don't know, but I could help you in the first one.
Here we are, let me go. So all right. The diagram below not drawn to scale shows two circles. C is the center of the smaller circle. All right, GH is a common chord. All right. That means the chord is common to both circles. And DEF is a triangle. Angle GCH is 88, right? They have it in the diagram. And GHE is 126. They have that as well. Calculate, giving reasons for your answer, the measure of angle GFH. We first need to figure out where GFH is. So where is GFH? Okay, GFH. That'll be over here, right? So, hey, this kind of look like the guy in his flag, you know? Yeah. Are you seeing it?
Yes, sir.
Yeah. All right. So Ria, what was your reasoning?
So for F, you're using the circle theorem that the angle at the center of the circle is twice the angle at the circumference.
Perfect.
And since it's 88, then F would be 44.
Big up you, right? Use our circles, boss. Right?
Well,
So guys, if we look at the diagram, if we look at this diagram separately, right? Separately. Let me call somebody. I just want to make sure everybody understands. Proseus. Proseus, you there? Perseus is not with us. Jira, are you there? Ways, boy. Way. It's crazy. Chelsea, you there?
Unfortunately,
Unfortunately, I like that. All right. So Chelsea, I don't know how familiar you are with circle theorems. The question, is it that I did CXC before or
yes, too much times.
too much times? You get through this time, you get through this time, right? So, okay. And if we look at this diagram here, and we have this small circle,
Yeah,
and you have an angle, and where's this angle going to?
the center of the circle.
Right? Where is this one going to? It also sounds the same. It kind of sounds like you're saying sir. Is that point?
Circumference.
Right? Is that point on the circumference? So if you have a situation like this, right? That the angle at the center will be 2 times the angle at the circumference. So you see how this is 88? It's got to be half that. So 44, right?
Okay.
Right, so GFH is 44. Right? And the reason for that is angle at the center is 2 times angle at nice. Right, GDE. Right, GDE. So first let's figure out where exactly GDE is. So
Excuse me, but what's the answer? Oh,
this is the answer.
for that's good. What was the answer for number 9?
Number
Um, PVR 75. PVR PTR.
for what?
Number 9. The one with the angles in with angles PVR and PTR. But a question asking for PTR.
Wait, you talking about this one? Oh, we didn't start that one as yet. Right now we're doing this question. When I get to the
Oh,
question, then I'll show you. Yeah. All right. All right, Ria, let's continue. So GDE. Where is GDE? All right, so GDE. That'll be over here. Right? So tell me.
so I know the what I think is the right one. The we call it the theorem, but
Let's see it. Let's see it.
but the answer I
Uh-huh.
was a little confused. So is it the cyclic quadrilateral?
That is performance. Big up you. Big up
Yeah,
full self. Right. It's a cyclic quadrilateral.
right. And all vertices lie on the circumference.
Right. This one is circumference. This one is circumference. This one is circumference.
Yeah. So the opposite angles would add up to 180.
Right.
But I don't know. I kind of stick there.
All right. It's not
So
a,
real simple. I don't know. I tap out.
all right. If both of them have to add up to 180, that means when I add this and I add this, I'm supposed to get what?
Wait, say that again. Oh, when you add. Oh, you see, I know that.
Yeah. What do I find for this?
So you have to minus 126 from 180, and
Right?
then you're gonna answer.
You get 54. Check that for more.
Yeah.
Nice. Right. So the answer for this is opposite angles in a cyclic quadrilateral add up to 180 degrees. Oh, bro, why that was 3 marks? That make no sense. Ria, that, that's crazy, right?
I mean, some people, for example, me probably wouldn't realize it's a quadrilateral in a circle. I don't know.
Okay. But you figure it out though. So I mean, yeah. Anyways, do y'all is there anybody in class that doesn't know what a cyclic quadrilateral is? Hey, look, Mira joined. Mira, good night.
Hello? Okay, this thing keep on connected. Sorry.
How are you? Are you okay?
I'm okay, and if you're gonna ask me about this question, I am going to
Cry?
not answer. Sorry.
You're gonna cry?
Yes, exactly.
Now, but like, okay, I'll ask you a quick question, right? And I promise I wouldn't ask you something I don't think you could answer, right? I wouldn't ask you, for instance, right? I wouldn't ask her to do my work here, right? I wouldn't ask her to do this. I don't expect her to know how to do that, right? Right.
I'm
But
question, what is that?
Even I don't know how to do that.
that is
What is that?
that's series. That's for a series.
Okay.
Basically, it's about sound waves, something like music.
Oh yeah, like physics.
Yeah. So
Okay.
this mathematical theorem over here allows us to break down, like it allows us to take a complex waveform, right, and break it up into a sum of simple waves. So like if you had like a complex signal, like I don't know, something like this, you could basically you could express this as a sum of this and this. It allows you to take a very complex waveform and break it down into simple ones. That's all. Yeah, but
Okay.
it's kind of
Question, for
hard.
instance, what would somebody need that for?
Yeah,
Like what you have to be studying in order to
either
learn?
yeah, that's what. Are you asking us so you can stay very far from it?
Yeah.
No, no, no. That's right. So, Mira, I wouldn't be asking you something I don't think you're capable of answering. So, they're asking us to find for GDE. Where is GDE? That's over here. Now, my question to you, Mira, what kind of shape is this? How much sides is this? How much sides is he in here? In this shape? How much sides?
Oh.
Okay, so what do you call a shape with 4 sides?
Um, it's out with a Q.
Yeah, yeah, it does start with a Q.
I know it's out with a Q, but it's not coming to my head right now.
A quadrilateral.
Yes, thank you.
Yes, a quadrilateral. And do all of the vertices touch the circumference?
Yes.
Yeah, so the proper name for this is a cyclic.
Quadrilateral.
Right. And if you have a cyclic quadrilateral, then the opposite angles had to add up to 180. So this is 126. Whatever this is, when you add it to 126, it's supposed to get 180. Understand?
Yeah.
Right. So that answer will just be 180
I
minus
was
126.
mistaken. It's for
Excuse me, what's the answer? Sorry to interrupt, but what's the answer for GFH?
DFH?
GFH.
GFH was 44 degrees. Yeah,
Oh,
was 44. Why? because the angle at the center is 2 times the angle at the circumference. So it is 88, then this angle here has to be half of 88, 44, because the angle in the center is 2 times the angle at the circumference. You understand?
Yes, sir.
Nice. Yeah, so Mira, you okay with that?
Yeah.
Nice. Good to hear you understand that.
And what's the reason for 54?
Oh, I just say that okay, 54. All right. So the reason for 54 is check the shape, right? And this is a quadrilateral,
Yes.
and don't all of the vertices touch the circumference?
Yes.
So we call it a cyclic quadrilateral. Anytime you have a cyclic quadrilateral, the opposite angles have to add up to 180. So that's the theorem there. So opposite angles in a cyclic quadrilateral add up to 180. Yeah. All right. So DEF now. Right. So real, let's continue. So DEF. Right?
Yes, sir.
DEF. All right. So we could this one easy to figure out. It only look at
I don't know if it have any theorems we work with. But since we know D and we know F, we just add it together and minus it from 180 and you'll get hold on 82.
right. So this can just be 180 minus 54 plus 44. There was no theorem for that. Right? You'll get 98. So that'll be 82. Yeah, 82, right?
Yeah.
Great. And now I know for a fact, Somalia, but I see that this is 54 degrees. I know that. I know that. Yeah. And you know people that already do that?
Me?
Yeah. You have to be very careful with these things. You have to be very careful. So if anybody is still confused, watch this. Carissa, I remember you was telling me that, this question was looking real tough.
It's not looking so anymore.
It's not looking so anymore. Nice. Because, like, look at this for instance. And if we look at the big triangle, and we already know that this is 54 and this is 44.
Yeah.
Yeah, so just 180 minus 54 plus 44, and get answer one time. Yeah.
What might come off was number was the second question.
So
Because
that
I really didn't study the cyclic quadrilateral.
I didn't study that. But you see it now, right? Yeah. Yeah. Maybe that is why it's 3 marks, because it's kind of hard to spot. Right? And the last one was 82 degrees. And if you want, you could put sum of angles in a triangle is 180 degrees. Right. I will you see this part over here? That's under a different topic. I know it technically is on a circle theorem. No, not circle theorem. It's under area and perimeter. It's under that. Right? Would you all still like to do the question now? Or move on to the next circle theorem question? It's up to you guys. I don't think it's that hard. All you want to do. Ria, let you be the decider. Do you want to do the area and perimeter question? Or
That's all good.
next circle theorem question?
I could try, but I don't know.
Okay, let me see. But I don't expect a little to get this off the top of your head, right? I don't expect that. Because it's technically like a different topic. So they want me to figure out the area of triangle GCH. All right. Did they give us any dimension? Okay, they told us that G to C is 4 centimeters. G to C. Okay, so G to C this here is 4 centimeters. Right? They're telling us that, and that is all they tell us, and they want us to find the area of GCH. Right. Do you have any idea how to approach that? I take it as a no.
Question, right? I don't want to sound dumb, but to me, that looking like an isosceles triangle and the other side is equal. So, I mean, all these sides can't be different lengths, right?
Yeah, I mean, you're right. This will be 4, and this will be 4, correct? But do we know what this is?
Um, no, that's
Ah.
fine.
Now, hear what, right? Hear what? Everybody would be accustomed with this formula for area of a triangle. And some of you never seen this before. Sure, I've seen this before. So this formula goes a little like this, a little something like this. You would have the height, and then you would have the base. Let me follow you see where I'm going with this, right? So you have the base, and so the formula for area would just be a half base by height. Does everybody know this formula? Yes or no?
Yes.
Yeah, but to use this formula, you need to know what the height is, and you need to know what the base is, right? Do we know what the height is? Tell me, guys, do we know what the height is?
No.
No, we don't. So and again, do we know what the base is?
No, so we can't use that to determine the area.
We can't. That is a different formula, right? Yay! It is a different formula, right? Okay, so I'm gonna show you a formula real quick. Right. So let's consider that we have this triangle here, right? Let's just say we have a triangle. We call this A, we call this B, and we call this C. If this is angle A, then this will be side common A. This is angle C, then the opposite side will be common C. And if it's angle B, then D. Then this will be side common B. Right? When I do trigonometry with you all, it will make a lot more sense. But just follow along for now. So if I have angle C, right? If I have angle C, then I could use this formula to find the area. It would just be a half AB sine C. Now, let me show you guys how I can apply that to the question that we have. So let's look at the question that we have. So the diagram that we have looks a little something like that. Right? This is 4, and this is 4. This is G, this is C, and this is H. Right? And the angle in the middle is 88. Right. So does everybody in class agree that we can't use a half base by height? Do we all agree with that? That we can't use a half base by height?
Agree, sir.
Right, nice. Because we don't have the base and don't have the height. I mean, you could if you wanted. If you wanted, you could split this in half. It's gonna be 44, or it's gonna be 90, and you just use trig ratios. But that's real working, right? That's real working. So show you how to solve it using this formula. All right, so Sky, I need your attention over here, right? So Sky,
Okay.
in this example, I showed you this new formula. You ever see this formula before? Ever?
A couple times, yes, sir.
Okay. So in this formula, we have two lengths, right? We have an included angle. So notice we decide to use angle C. You see in that?
Yes, sir.
And didn't we use the sides that was next to the angle,
Yes, sir.
right? So if I want to use our formula over here, look at what I'm going to do. If this is angle G, this will be common G, right? If this is angle H, what would this side be?
Common H.
And if this is angle C, I'd call this side what?
Common C.
Right. Now, if I want to find the area, it's going to be a half of the sides that include the angle. So Sky, what's the only angle we have in this question?
88 degrees.
Right. What are the two sides that are next to that angle? So this is what I mean.
Or G and H.
G and H, right? So my formula is going to look like a half G by H sine, and my angle is C. On a scale of 1 to 10, how much does that confuse you?
So not as much as I think it should.
That's good, right? And so now we can put in the information. So what is G and H?
4 centimeters.
Right, so we're going to write 4 by 4. And what's the angle?
88 degrees.
Right, so this is a perfect opportunity for me to show you how to use the Casio. Right, it's a perfect opportunity. So what you're going to do is, right, you are going to press the fraction button. Right? When you press the fraction button, are you seeing what is on the screen?
Yes, sir.
Right? You're going to put 1, then you're going to press the right arrow, and that should carry you to the denominator. Yeah?
Yeah.
You're going to put 2, then you're going to come out of the fraction by pressing the right arrow again. So you should be seeing a half, and the cursor should be outside. Yeah?
Okay, so yeah.
Gonna open up a bracket, gonna put 4, gonna close the bracket, gonna open up another pair of brackets, put 4 inside. Then you're going to press the sign button. An open bracket should come up. Then you're going to press 8, 8. Close bracket. Then press equal and you should get your answer.
So I have an answer here.
What you got?
7.99.
No, I'm not gonna get that because my calculator in radians mode. I need to convert that to.
Oh,
Let me just do that real quick. Right. Nice. You get 7.99.
yes, sir.
If you round that off to 2 decimal places, what are you gonna get?
8.1.
I'm gonna get 8.00.
Okay, 0, 0. Yeah, my bad.
You're wondering why the second decimal place is 9. The number after 9 is 5. So you're going to add 1 to 9, but that's going to turn to 10. So then you're going to add 1 to the other 9, that's going to turn to 10 again. And then you're going to add that 1 to 7, that's going to turn to 8. So you get 8.00. Yeah?
Okay. Yes, sir.
Nice. So that'll be 8.00 centimeters squared. Now, guys, I get that this is a new formula. So if you'd like me to run it over again, tell me. I don't mind going into it. Is there anybody that'd like me to go over the formula?
Well, so I could.
Okay, I'm happy to hear that you good. I'm not hearing anybody, boy. Hey, boy.
Good, I good.
Very good.
Right, Sky. Sky, you see how they're moving on? They're moving real dry, eh?
So I can go and bite them or something.
Yeah, boy. Right, so we know how to find for GCH. Now, this is the formula you can use anytime you have an included angle. You will hear me saying that a lot. All an included angle is, all it is just an angle with two known sides. That's all. So, if any of you are confused, watch. So, Sky, and you see we have an angle here?
Yes, sir.
What makes it included is because it's between two known sides. You know the length of the two sides that included. So yeah, cool. All right, let's move on to part 2. They want us to figure out the area of the minor sector bounded by arc GH and radii GC and HC. So again, these are formulas I'm probably not familiar with, but it's okay. We'll figure it out. So they want me to figure out the area of the minor sector bounded by arc GH. Okay. All right. All right. All right, the minor sector. They want us to figure out for this. Do you understand that, Scribe? I know it looks very, very convoluted.
So is it the two radii with the arc?
Yeah.
Mm,
Sorry, I think over here. Understand?
yes, a sector.
That's the sector they're talking about. Now, let me
Okay.
ask you something. Do you remember how to find area of a regular circle? What's the area of a regular circle? Does anybody know? How do you find the area of a regular circle? Guys, it's kind of concerning, that a little concerning. Normally, I wouldn't judge anybody, yeah. But guys, all you have to know what the area of a circle is. Have to. Do you all know? Ria, you know what the area of a circle is?
Um, by something.
Pi something. I like that. Pi r squared, right? Pi r squared. Now, Ria, if we're talking about a sector, isn't a sector just um part of a whole circle? Tell me that makes sense. Watch. If this is a whole circle here, right? If this is a whole circle, and we just considering this, isn't that just piece of a whole circle? Yeah or no?
Yeah.
Yeah. And if you're all confused by that, Ria, are you confused?
No, sir.
So you understand that the sector will just be a fraction of the entire circle. Yeah?
Yes, sir.
Okay. So are you able to figure out what fraction it would be of the entire circle? Just remind me. What's the sum of angles in a circle?
360.
Right. So if I wanted to figure out what fraction this would be, it would be 88 over what?
Over 360.
Right. You understand what confusing here?
Ade.
Okay. I'll go it over. Right? Don't like that. A day. Just now we go into a week. I don't know if you see what I do there. That's a good one. Right? Because then you said a day. And I said a week. Yeah. Right. But anyways, can you see? Okay. If the whole circle is 360 degrees, right? Right?
Yeah.
And this is what angle of the whole 360?
Um,
Don't overthink it. Watch.
like half.
No. Don't overthink it. Righty.
88 degrees.
Right. So
Okay.
do you understand that this small section is just 88 degrees of 360 of the entire circle? Okay, because watch, wouldn't the whole circle be 360 degrees?
Yeah.
But how much degrees is taken up?
88.
Right. So it'll be 88 of 360. Tell me if that makes sense.
Yeah, it makes sense.
But let me go through an even simpler example. Don't feel like I'm judging you or anything. It's just for the humor. Don't. You're feeling bad?
No, not really.
Okay, good. Check this out, right? Imagine we had this circle, right? And I tell you that this is 180 degrees. What fraction of the whole circle that would be?
Half.
A half, right? Because 180 over 360, yeah, half, right? So that makes perfect sense. Nice. So we're on the same page, right? The area of a sector would just be a fraction of the entire area of the circle. Yeah or no?
Yeah.
Right. So which fraction? Well, to figure that out, you're going to multiply that. You're going to multiply it by theta all over 360. Don't get too confused. I promise it's real simple. So let's apply everything we know. So they told us to use pi as 3.14, so I'm going to do that. What was the radius for this sector over here? Tell me, remind me.
So sorry, I didn't hear you.
What was the radius for this sector?
The radius for this sec. 88.
88. So our radius is a point from the center to the circumference. So if you're going from the center to the circumference, that'll be that length over there.
Oh,
And they told us that it was what?
4.
Right.
My bad.
Okay.
I just
Yeah, 4 was our maths. So, and ends out of the whole circle, that sector is 88 degrees.
Sorry, sir?
And out of the whole circle, this sector is 88 degrees.
Yes.
Right? So you're going to be 88 over 360. Right? And when you plug that into the calculator, you should get your answer. Right?
Oh. Wow. Okay.
Right? So that's going to be 3.14 by 4 squared. Right? So Sky, all of this is practice, right? For you to get to learn how to use the calculator. Right? 88 over 360. So Sky, I'll wait on you. I want you to tell me your answer.
So have 12 points.
Huh?
Say what I say.
Say that again.
So I had 12 points.
Nice. I just wanted to make sure I get the answer now on the calculator. Yeah. So that'll be 12.28 centimeters squared. Is there anybody that's extremely cooked? Tell me, guys. You know I will go it over how much times I need to go it over. That's fine.
So I could just go over one more time.
Okay, no problem, Sky. So Sky, do you understand that the area of our whole circle, our entire circle, is pi r squared?
Yes, sir.
Now, how much degrees is our whole circle, Sky?
360 degrees.
Right. So this would be for 360 degrees. Now, Sky, if I wanted to, oh wait, first of all, can you see that a sector is just a fraction of the whole circle? Can you see that?
Yes, sir.
Nice. So, but what fraction exactly? What's this angle over here?
88 degrees.
So out of the whole circle, and if I wanted to find a fraction, I would say 88 over 360.
Yes, sir.
So essentially, this area would just be this fraction of the whole area. Let me know if you understand that.
Oh, okay. Okay, sir.
It's clicking now.
Yes, sir. Clicking.
Nice. So we just finding a fraction of the whole area. Because that's what it is. Right? A sector is just a fraction of the whole circle. So cool. I gotta ask all the questions from like today, because next class I want to move on to something else. Right? I'll give all some homework on circle theorems, but I will not be correcting that in class. I will do up the solutions and send it. And if you do the homework, I'll correct it. But next class, I want to move on to something else. Right? And now we need to figure out this shaded segment. Okay, so Sky, since you're here, right? Max, a question. If I wanted to figure out the area for this piece over here, how would I do that? You have any ideas?
So, my brain just kind of went blank.
That's okay. Let me focus on what we just now found. And we just now found this entire area.
Yes, sir.
Nice, we know the entire area. Didn't we also find for this?
Yes, sir.
So here it is now. If I know what this area is, and I know what this whole area is, what do you think I could do?
So, art and teacher.
Nice. Some of the opposites are what I wanted to hear.
So subtract that from each other.
Right. Let me show you why I'm saying that, right? Let me show you why. Watch this. Okay, so and we just now found this area over here. This area in blue.
Yes, sir.
Nice. And what other area we find for? Check it out. And we also found for the area of the triangle GCH.
Yes, sir.
So wouldn't that be over here?
The triangle, yeah.
Now stay with me. I want you to notice where the areas are overlapping. Now, if I'm minusing and the areas are overlapping, what would happen there? If the where the areas are overlapping, that's going to turn to what? What number? If I'm minusing, what would happen to the areas that overlapping? So imagine I had an area of 5, and then I take away 5 from that. What that would be? If you're talking, I can't say. I'm not hearing anybody as a matter of fact.
That is 0.
0, right? So where the areas are overlapping, and that's going to actually turn to 0. So by subtracting, we actually end up with the shaded region. So Carissa, tell me if you understood that.
Yeah. But what we minusing?
Okay, so check it out again, right? So they want us to find the area of the shaded portion.
Right.
Didn't we find the area of the whole sector over there in blue,
Yeah.
right? And we also found the area of the triangle.
Yes.
So if I subtract the area of the sector,
Oh,
area of the triangle, wouldn't they just cancel off each other and leave me with the shaded region?
yeah.
You're sure you understand that?
So we minusing the answer we get from 1 and the answer we got from 2?
Yep. So we're going to say, just to figure out part 3, right? The shaded segment, that's just going to be equal to 12.28
Minus.
and so you get 4.28.
Okay.
So again, you understand how it works, right? Because if you subtract this area from the whole area, then this would cancel off and it would leave you with this. Tell me if that makes sense.
Yeah.
Nice. All right, so we answered that part. Nice. Question 9. I do question 9. So which brave soul wants to help me with question 9? Which brave soul? Do we have any brave souls? Guys, all I want to see our engineering student do a circle theorem question. A cough cough Tavon.
Me?
All I
Me?
want to see if Tavon could do this.
Yeah.
Well, only one person say yes, so that's not very convincing. So
Yes.
Yeah, man.
so Tavon, it looks like you're going to skip that. So basically what they are saying is they want me to call upon them. That's what it's
Mhm.
I feel so. Jada, I feel like you could help me with this question, you know. Wait, boy, the only person talking to me in this class is Sky.
So, you hear, man?
Yeah, yeah, yeah.
So all the time I'm asking him to hear, man. Yeah, and tell me nothing, sir.
I know here, yeah. But here's the interesting thing. If your mic isn't working and you're asking me if I could hear you, you wouldn't hear me say anything because I can't hear.
Oh. So will I fix it?
Okay, nice, I hear you now. Right? Yes, Sky, you feel like Tavon should try this question?
Yeah, so of course.
All right, Tavon. Devon, yeah, kind of at a disadvantage here because you didn't do CSEC maths in a very long time.
Well, I ain't do see. I hardly do like yeah, it don't really matter. If I
But
attempt the question or not, because well, I really at a disadvantage because I ain't been paying attention for the last so been doing my own thing. But
that's okay.
I will shoot at it if I could, you know.
All right, so Devon, just running through the basics, right? If you have an isosceles triangle, base angles are equal, you know that, right?
Yeah, man.
If you have a straight line, what's the angles along the straight line?
180.
You have a whole circle, what's the sum of angles in a triangle? Sum of angles in a circle,
At 360.
right? If I have four sides, what am I?
Quadrilateral.
Right, and if all of the vertices touching the circumference, we call that cyclic quadrilateral, meaning that
Yeah.
the opposite angles had add up to 180, right?
Mm-hmm.
Another one you should know is that if I have two angles at the circumference standing on the same arc or chord, then the angle at the circumference would be equal. So that's essentially all you should know, right? And you should also know, actually, never mind. I will figure it out when we do the question. So they want me to figure out PTR. Do you agree that PTR would be over here? So PTR.
You're looking like a right angle there, boy.
Here?
No. The triangle itself. Okay, if we connect R back to P, looking like a right angle.
You know, you bring up a good point because it would form a right angle. And you know why?
Mm.
This angle
You
form,
could see it form like a form of card right this way, yeah?
wait, it actually wouldn't. It actually wouldn't. Let me explain
Yeah,
why.
boy.
Guys, oh, Sky, do we know for sure? I'm just passing through the center of the circle.
Nah.
No, sir.
So you can't assume that. If you did see this, however, then yeah, you could assume it was 90, but you're not seeing that. So never mind. So it's a fun. You don't understand what PTR is, right? So PTR will be over here. That's what PTR.
Right.
Nice. And this is real easy. Check this out. What do you think the answer is?
Is you remember I said like how if the angle and standing upon like two opposite the same arc or card is the opposite angles, right? That's how mixed out.
I get what you're saying, right? I get what you're saying. You're talking about like this on this.
Yeah.
But my question is, you can only use that if you know one of the angles. Do we know what this angle is?
Nah, we don't know that.
Yeah. So you had to use the information you have to figure it out. So make a guess.
75, eh?
Yeah, I 75. So Tevon made a guess. Could any of you guys actually tell him why it's 75?
To me, them two they look the exact same though.
Yeah, they do look the exact same. But why?
Is it because angles in a segment are equal?
Yeah, I have a little more to say to that. But yes. And
Because they're standing on the same chord.
right, yeah, close. In this case, it would be arc. I would use the word arc. If I did connect it, though,
I see the arc there.
but Rhea, do you see any arc we talking about?
Yeah.
Yeah. That's why any theorem I always say arc or chord. That's why I just say that. Right? That's why I just say that. So you can use the same theorem, right? Arc or chord. So can you see that both of the angles standing on the arc PR? Do you see that? Some of you seeing that? Yeah.
Yes, sir.
Right. So angle PTR is equal to 75 degrees. Why? Because angles in the same segment standing on the same arc or chord are equal. Yay! Right, to
Yay.
maths. Right, now we have to figure out TPQ. TPQ.
TPQ.
TPQ.
That's the opposite angle there.
Now take your time. Take your time. Remember what I tell you, right?
Oh, no, no, no. Yeah.
This would be the opposite angle. Right?
You're right.
But you could use that, like you're going good, right? You had to use cyclic quadrilateral. But the thing is, right? If you're using cyclic quadrilateral, you need to know at least what one of the opposite angles are. So Tivon, if I wanted them, I can figure out for this now because I have this 75.
Yeah.
Right. Cool. My question to you, right, is if I knew what this angle was and I could figure out this angle,
Yes.
yeah, could I figure out for this angle?
You can.
Oh,
Because you just minus that from 180.
right. Engineering brains here, you know, guys. Quick with it. Even though he rusty, quick with it. Big up to one. Right, so that'll be 180 minus 60 degrees. So that will be 120 degrees. Nice. All right. So if this is 120 degrees over there, what would this be?
Same thing.
No, no.
No. Wait, hold on.
Remember, opposite angles in a cyclic quadrilateral have to add up to 180 degrees. So that's 120. If this angle is 120, then whatever added here must be equal to 180.
Oh, so that means now on is 60 then.
Yep, it's 60. And the working for that would be 100.
Hold on, sir. What did you say was the answer for PTR?
PTR was 75 degrees, and the reason for that was because angles in the same segment standing on the same ankle chord are equal. So Joshua, can you see that both of those angles standing up on arc PR? How have you seen that?
Yes.
Nice. So they're equal then. Right, so that was it there.
Mm-hmm.
Right? All right, give me a second. I just highlighting this so everybody will be able to see it properly. Yeah, so I think we could see the cyclic quadrilateral for sure now. We could definitely,
Yeah, niceness.
right? Nice. And angle TPQ, that's really simple. That would just be equal to 60 degrees. Why? The reason for that is because opposite angles in a cyclic quadrilateral add up to 180 degrees. So we use that, and we also use the fact that sum of angles along a straight line is 180. So let's put on all the work in, right? Let's put on all the work in. So if I want to find for angle TRQ, which is this angle over here, TRQ, that was 180 minus 60 degrees, and that's what we got 120 degrees, right?
Yeah, that just being I say.
Right, and the other piece of working to find for TPQ would be 180 minus 120 should be 60 degrees. As the full working there, right?
Yeah, note that down, fellas. Cause
Yes,
this ain't not for me right now. It's for y'all.
exactly. It's for you. Carissa, how do you find this going? Everything making sense?
Yeah, it makes sense. It's just a matter of taking your time and watching.
Yeah,
Yeah, because it's
I'll
a lot
take your time.
sometimes. It's a lot sometimes.
I got a tip for all of you too. Like, don't afraid to be wrong. Just dish out some answers and you go get corrected along the lines. But not shame me, so So just try. Once you try, that's all that matters right now.
Exactly. If you don't try, you will never learn. You gotta fail to succeed first, you know?
I throw out all the answers, and if you're not wrong, you try again.
Yeah, that's
So
it.
yeah, that's it. There. So don't always volunteer, even if you're wrong. Be proud that you're wrong because you could correct yourself. Better to be wrong now than to be wrong in the exam, because I know if you're wrong in the exam, you're gonna come home balling.
That is the truth, right? Big up your co-host one time, spitting some very real advice, right? Teflon, I don't know what's going on with the vibes of this class, you know, like the vibes like drain. Like I don't know what vibes it have. Wait,
No, but like I'll catch them any day, boy. When they
yeah,
wake up and full of energy.
yeah, boy.
'Cause no, I just find like they want to sleep. Like.
I find so too. But we had 21 minutes again. Oof, that'll fly by fast, right? Yeah. So Ria, I want your help more with part three, right? So Ria, read part three for me there.
Obtuse angle POR, where O is the center of the circle.
All right. When you hear obtuse angle, you know what that is?
I know it. Is it an angle that is more than 90 but less than 180?
Bingo.
Yeah. Yeah. Let me run through
Yeah,
what
because acute is less than 90. You get right angle, which is 90. Obtuse is
Yes, yes.
90, less than an 80, and then your reflex is more than an 80.
I tell all the engineering. We are boss engineers, you know. Boss engineers. We had to know all of this.
Yeah.
What I say, we don't even use it.
Well, we don't even use it, but if we don't know it, we cooked.
Yeah, cooked. So obtuse, it is okay, so you have a range, right? So obtuse has to be more than 90, but less than 180. So that's that one right as 90, right? Yeah. And well, right. Reflex is when you pass 180, right? But I believe you're in between like 180 and 270. Let me just verify. Oh, never mind, it's 360. Yeah, cool. Right. Great. Cool. That's essentially where I'm right? So obtuse is the one in the middle. So 90 to 180. Right? So Ria, let's figure that out, right? POR. POR. Wait. Where O is the center of the circle. But where is O? That's the real question I have.
We have
CSEC
center.
results?
That's the realest question. Where the center there?
Yeah, because I don't think we could just draw a center there and call out a day. That's kind of weird.
Where O is the center? You see now, oh boy.
That
I see zeros.
yeah, XC cannot do it, sure.
O is the
Because
center, boy.
if you go to do that, let me see.
Like what they want you do, they want you measure the diameter and just find the middle and just call a day, boy.
I find like this.
End to end.
Okay, you could figure it out, right? You could figure it out. Let me show
Pull
you.
up a ruler there.
Let me show you how you would figure that out, right? Let me show you how you would figure that out. It's a kind of dumb question, but oh well, we're not adding over here. All right. So I'm going to use a theorem. So guys, check what's going on here, right? So real, I'm gonna if you're there with me. You there with me?
Yes.
So we had to add in a center because it didn't give us a center. Understand?
Yes, sir.
Yeah. Now, enter have a theorem that says angle at the center is 2 times the angle at the circumference.
Yep.
Yeah, that's true. So if we can somehow figure out this angle, which is at the circumference, and I could just multiply it by 2 to figure this out.
Yeah.
Yeah, let me show you how all of this gonna work out, right? So let's pay attention to this cyclic quadrilateral. Let's pay attention to it. If this is 75 degrees, what do you think this would be?
Whatever 180 minus 75 is.
Right, so that's 105.
Right.
I see that question now, no worries.
No, well, kind of, but I hear.
Nice. Right? And this is the part where it's kind of interesting. So we understand that there's 105 degrees over there. Yeah.
Yeah.
So the angle at the center would be what now?
Half of the.
What's half of the?
Is half? Yeah.
Yeah.
That
But
would be
wait.
52.5.
No.
Oh.
Not so fast. And you had to be very careful here. Because when it could be over here. It could be over here. Yeah, because with 2 times 105? What's 2 times 105? What's 2 times 105?
210.
Right, 210. And remember, they wanted us to find the reflex angle, eh? Once they reflex, the obtuse. If they were to find the obtuse, do you think it would be this big angle over here or the angle on the inside?
No, it'll be the angle on the inside.
Right. So then, where's the sum of angles on our circle?
360.
360, right? So, if this is 210, what is it going to be?
360 minus 210.
Yeah.
And that'll be 150.
Tricky question. Which marks that was for? 2 marks? That's crazy. I feel like CXC make a mistake and just left out the O. And that's honestly why I feel. Yeah, that is what I think happened. Right? But this is the correct way to do it if you put out O. Right? So I put a question mark by this question. Because something kind of sus. But I showed you all how to attack it still. Right? This is correct. So the correct answer will be 150 degrees. But that's plenty working for 2 marks, which is kind of sus. And they never give you a center to begin with. Right. So we have 14 minutes remaining. Let's do another question. So here what? I want one of you guys to pick a year. Pick a year.
So what are you trying to?
Which one? May, June, or January?
May, June.
That's crazy. You just pop up on this circle theorem question. This guy, you see that?
I see.
It just pop up. Like when I open the document, it just popped up on the circle theorem question. That's crazy. So let we handle this question, right? So H, J, K, L, and M are points on the circumference of a circle with center O. MK is a diameter of the circle and it is parallel to HJ. MJ, Michael Jackson, is equal to JL. An angle JMK, that kind of sound like Jamaica, is equal to 38 degrees. Okay, so let's pick out a couple pieces of information. So Sky, aren't they telling us that this and this parallel?
Yes, sir.
I can see through the arrows and
Yes, sir.
yeah. Now, anytime I see parallel, anytime I see them talking about parallel, hey, just know they're gonna ask something about alternating angles. Please, just know they're going to ask you something about alternating angles. And if you don't know what alternating angles are, that's why you're here. Don't feel shame. So alternating angles is basically this. If you have two sides that are parallel to each other and you draw a diagonal line in the middle, then the angles in the alternating segments will be equal. So Sky, you see this over here? That angle over there?
Yes, sir.
That will be equal to this angle.
Yep.
Right? You see this angle over here? Y? That'll be equal to this angle. Don't know if you understand.
Yes, sir.
Great. Explain giving a reason why angle HJM is 38 degrees. I'm pretty sure it's gonna be because of alternating angles. All right, let me see. So where is HJM? HJM. That's over here. Sky, what's the reason for that?
So come again.
What's the reason for that?
HDM.
Yeah. Why is HJM 38?
So because it's an alternate angle to
Yeah, alternating angles are equal. Yep.
yeah.
Let me just highlight it so everybody can see it. That's what I'm talking about. So HJ and MK are parallel. So that forms an alternating angle network. Right? So hope you all understand that. So if this is 38, then this would also be 38. Right? So the reason is alternating angles are equal. Uh-huh. No, MJK. MJK is equal to 90 degrees. So MJK. MJK. Sky, why is that 90 degrees?
So well because what angles inside our semicircle is 90 degrees.
Right. Easy thing, man. Easy thing. Pick a nice here. Right? The angle in a semicircle is 90 degrees. Right? All right. Determine the value of each of the following angles. Show detailed working where appropriate. Now, be careful. Sky, before we continue, let me just put in all the information we find out. So, and we know that this is 38,
Yes, sir.
right? And we know that this is 90,
Yep.
right? They want me to find for MLG. MLG, where's MLG? Right? Right, so MLG. That's over here, right?
Yeah.
Okay, great. So you see any theorems that we could potentially use for that?
I see in theorems, but it's not going to help. Not going to help.
Are you seeing this one by chance?
Yes, sir.
That one will help. But for that one to help, what we gotta find for first?
MKJ.
Yeah. We could find for that, you know?
So we know that in that triangle it's have 38 degrees and 90 degrees. So yeah, 90 plus 38 subtracted by 180.
Let's do some mental maths fast. That would be 50, 52. Would it? Check it.
That's not. Yes.
Badness. All right, so that is 52, and it's gonna be 52.
Yep.
Great. So let's break down our reasoning, right? So the first thing you need to write, well, you need to say that angle MKJ, 90 degrees. 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 90 deg would be equal to 180 minus 90 plus 38. Because obviously you're not going to have the diagram when you work in the question unless you have real time and you could draw a diagram for every single thing. Right? It's going to be 90 plus 38. So if you don't have the diagram, just refer to it like this, right? So 52 degrees, right? And then you could say that MKG will be equal to MLG, right? And we're going to say Y. Right? So angle MLG will be equal to 52 degrees for Y. You had to say angles in the same segments standing on the same arc of chord are equal. Great. Mm-hmm. Cool.
I have a question, right?
Mm-hmm.
You can't say that all the angles in the triangle have to equal 180 degrees.
I mean, you could put that if you want, right? But it's the main focus of the question. The main focus of the question was
Um,
angle the same segment standing on the same arc of chord are equal. But sure, that wouldn't kill you, right?
okay.
Because you realize it's a 2 mark question, right? So 1 mark is for like this alone is plenty marks, right? But essentially this is 1 mark and the reasoning is 1 mark.
Right. So doing the same working for MLG, right? You can't just use that wording instead of on the same arc of chord. Because to me, when I watch it, I know one angle is 38 and I know the next angle is 90. I didn't even watch the like to be on the same arc or chord. I just see well, okay, everything in the triangle is a full triangle. It has to equal 180.
Right. But here this, right? Get this.
Mm-hmm.
So they're asking us to find the MLG, you know. MLG
That's
actually over here.
right.
But what we use to find for that is we actually use this to find it.
Okay.
Tell me if you agree with what I'm saying. If we try to find for MLJ using this, do we have enough information to find for this?
But and we said J was 90 degrees.
Uh-huh.
You know, M is 38.
Right. But watch. If I'm looking at this triangle over here, that
Right.
38 is only for this piece over here. It's not for the entire thing.
Okay.
This 90 is for this, not the small piece over here.
Okay.
Okay. So what we actually used to find for this, we actually used this triangle over here. Because in this triangle, we know that this is 38, we know this is 90. Right? So we found this to be 52. And so Curison, now you have to tie it back into this. And this angle we just now found for. And this angle. And both of them standing up on the same arc of chord, MJ. So that is now how we could come and say that this is 52 as well.
Okay.
You don't put that, gonna lose a mark.
Ooh,
Yeah, you're gonna lose a mark. You have to put that. Have to.
okay.
Everything you gotta justify. Right? So I'm just gonna put in new information we found for. So this is 52. This is 52 degrees. This is 90. Right? This is 38. So any piece of information I find for, please put it on one side. Now we want to find for LGK. Right? So sky. LGK. LGK. L. So that'll be LG key. That's over here. The sky. Let me see what you're gonna find for that. Maybe a tough one. Sky,
That one show.
you're unsure.
Yeah.
Okay, don't worry. We'll figure it out together.
Okay.
All right. Let me think for a bit. Okay, I see how to do it. Right? So, Sky, if we look at, I don't know, you had to do real questions to develop this skill. I mean, real questions. You had to just like keep doing it. The funny thing is, when I was in school, I wasn't so good at this. It's only when I started teaching maths, I become good at it. I don't understand why. I don't understand how. I don't know. I feel like when you're not in the school setting anymore, you just like do better at it, right? But Sky, I'm bringing attention to something. Wouldn't this triangle here be an isosceles triangle?
Yes, sir.
It's an isosceles triangle. That would make this side. What would I make this side?
52 degrees.
Mm-hmm. I think that is 52 degrees. Is it possible for us to figure out this?
Yes, sir.
How would we figure out this?
So, add them together and subtract them by 180.
Right, so that'll be 180 minus 52 plus 52. So that'll be 76, I think.
Mm.
Check it. Let me figure 76.
Yes, sir.
So check this out. Everything gonna come into the picture now. Oh, that question. It's right. What's this entire angle here?
90 degrees.
We know that this piece is 76. How would I find
Mm-hmm.
this small piece?
So 90 subtracted from 76 degrees.
She get 13.
So I get 14.
Yeah, never mind. I know it on my head. Yeah,
Yeah,
76. I thought it was 70, 77. I don't know why.
it was close.
No, I could have swear this was 77. No, I don't know how. Right. Yeah, so that's gonna be 90 minus 76, which is 14 degrees. So yeah, man. 1 mark? Bro, what? What are they on about? Has something I didn't see or something? Let me see. Bro, what? Give me a second. It must have been some easier way to work this thing out. The only other way I've seen, like if this is 52 degrees, right? Sky, can we agree that this is a cyclic quadrilateral?
Yes, it is, sir.
So if this is, but even then, man, kind of weird. It's gonna be 52. So that would help us find for this. I'm sure that's the next part, by the way, but 1 mark. It's kind of crazy. I don't know what I'm thinking. Was he? Because that was a lot of working for 1 mark. Hmm.
So I think I don't know if that's correct, but I just added 38 and 38 and I got 76 degrees.
But 76 is not the correct answer, eh?
Yeah, I know.
I'm trying to see the connection. Wait, let me look at this triangle. 1 second. Yeah, add to the 8 onto the 8, but why? Yeah, I'm not sure that. Like, this is the only way I see it today. And all the other ways I see it in my head's like very, very long. Like much longer than this. Yeah.
I thought the one that I do first was the easiest one. But 1 mark is crazy.
Yeah, 1 mark is kind of crazy. A little kind of pushing it. Hmm. Oh, I figure it out. Damn, that's crazy. That's actually crazy. Sky, you want me to show you it? You're gonna be like mind blown.
I said, but
Okay. You understand that this is a isosceles triangle, right?
yeah, sir.
Like this, right? Wouldn't wouldn't this angle here be 52 minus 38?
Yes, sir.
It's 52 minus 38.
214.
Yeah.
Wait, wait,
No, but
sir.
watch this, you can see it. So essentially, um, angles standing on the same arc or chord are equal. Watch. Right? Right? See it?
Nah, sir. I can't believe I didn't even see that.
I only just now see that. Like I look back at it and I was like, oh, wait a minute.
When
Maybe if they had drawn a chord, we'd have seen it better. But
probably.
they were standing up on an arc.
Yeah.
They have multiple ways you can answer this question, but the answer is 14 degrees. Right?
Mm-hmm.
Right? I'm going to put on the second one because that's writing for me. So Sky, let's put on the reasoning for the second one, right? So for the second one, you would say we could say that that's triangle MLG is an isosceles triangle, right? Therefore, angle JLM would be equal, right? JLM would be equal to JML. And from there, we can find from angle LMK, right? So LMK would be equal to 52 minus 38. So you get 14, right? And then you would say that LMK is equal to LJK, right? Because angles in the same segments standing on the same arc or chord are equal. Yeah. But for still 1 mark, that's not working, but you're pushing it. Uh, Angle JHM. JHM. All right, GHM. GHM. This is really easy. Sky. This is actually a 1 mark question. This is what a 1 mark question is supposed to look like. So this is 52 degrees. And so what is going to be? Thomas Sky. You know the answer already. It's really easy.
2 degrees.
Huh? What will it
That's
be?
it. 2 degrees.
32.
Yeah.
Nah, you lost my day. What kind of track? What kind of shape this is?
A cyclic quadrilateral.
So if I know this side is if I know that angle is 52, what is it gonna be?
52.
Say that again?
52.
Oh no. Nah. Remind me where's the theorem associated with cyclic quadrilaterals.
All opposite angles add up to 180.
So if this is 52, whatever this angle is, and I'll add it, I suppose say 180.
Yes, sir. So 180 minus 52.
Yep. And you should get 28.
28, yeah.
Right? That one real simple. This is essentially they're working on the reason is opposite angles in a cyclic. Right, let me know if you understand.
Yes, sir.
Right? That's it. So let me just get like a survey, right? Well, what do you all want to do in the next class? Are looking at trigonometry, matrices, or vectors? What do you want to do? Trigonometry, matrices, or vectors? What do you want to start in the next class?
Vectors.
Vectors? All right. What are the rest of you guys?
Yes, sir, vectors.
Yeah, I guess I can now too.
Simon, hey, the vectors you doing, and you
Yeah,
much different from these vectors. But I suppose it
real
can
talk,
understand the concept.
real talk. Yeah, boy.
Yeah, like when you find in my matrix.
They ain't too bad, but it's real pressure. But I like do all that one time and come back and do a different thing.
Yeah. Because the vectors you all will be looking at is vectors in a two-dimensional space. So like, like up, down, left, right. But like when you do keep and you start like if you do an engineering degree, you're looking at three-dimensional vectors. So you could move like in three dimensions.
The man nearly give you a 4 dimension one at a time, boy.
No, I don't think they would ever do that.
I don't think they, but the guy that does do the tutorial and thing, boy, the man throw down a 4D vector and say, they will try visualize it because we can visualize them kind of thing.
Yeah, I
Just
remember.
as an example, no?
Yeah, because of that, a matrix and a vector could correspond to any amount of dimensions, technically.
Yeah, boy.
And
Man just do that for show,
yep. So yeah, guys, vectors next class. It depends on how much are they awake. Ria, you are awake?
Sorry, sir.
I'll wake you up, I'll wake you up, I'll wake you up, Nick.
No, I was waking.
I'll wake you up. Either that or I'll catch you in the middle when it was doom scrolling on TikTok.
Nah, I was here,
Okay, so like what do you want to do next class? Is that
So
everything?
I say vectors.
Oh, you say vectors? Okay.
Yeah.
What about the rest of all your like are they Kabi on Earth? They're not here, but Perseus, Carissa, Simran, Aditola, Mira, Joshua. Vectors next class or matrices or what do you want in the next class?
Well, I was a bit confused with matrices, a little bit,
Uh,
but I guess we could go over in class.
okay. Well, since most people say vectors, I will do vectors. But if you do any questions on matrices and you need help, tell me. Because here what Joshua, right after vectors, I will do matrices.
Okay.
Yeah. So guys, thanks for coming to class today. I will see you all next week. Asking some more tomorrow. Later, everybody.
Later.
The weekend, sir.
Thank you.
I sir.
Later.
Bye.